Hi, in this video, I will be showing you problem number 31 of chapter 10 section 2. Use the parametric equations of an ellipse x equal to a cosine theta, y equal to b sine theta, where theta lies between 0 and 2 pi to find the area that it encloses. So, from calculus 1 class, we know that area under a graph of a function y equal to f of x bounded by the lines x equal to a and x equal to b is integral y dx. That is the area. Now in our problem, the graph is an ellipse. Graph is an ellipse at theta equal to 0. When theta equal to 0, x equal to a cosine of 0, which is equal to a. When theta equal to pi by 2, x equal to a cosine pi by 2, which is equal to 0. And also we know that the graph of an ellipse is symmetric with respect to x and y axis. So in order to find the area of this whole thing, in Cartesian form, you can find the area of this one piece and then times by 4. So it is only all these are equal areas and 4 times the area under the graph between 0 to a. So area of the ellipse, a equal to 4 times integral 0 through a y dx. Note the limits are for x running from 0 to a. So here we can now use the parametric representation. 4 times y in the problem is given as b sine theta. So y equal to b sine theta, and dx, as x is given to be a cosine theta, dx is negative a sine theta d theta. So it is negative a sine theta d theta, and then x equal to 0. So everything is now changing to the variable theta. So x equal to 0. So x equal to 0 actually corresponds to theta equal to pi by 2. So theta equal to pi by 2. Then x equal to a corresponds to theta equal to 0. Theta equal to 0. So we get area equal to 4 times, then inside you have AB that can be pulled out, integral pi halves through 0, then we have negative sine square theta d theta. But as we have the limits pi by 2 to 0, if you switch it, then you can get rid of the negative sign. It is 0 through pi by 2 sine square theta d theta. So by switching the limits, you will have to introduce the negative sign. There is already a negative sign that become positive. So it is integral 0 through pi halves sine square theta d theta. So it is 4ab, then integral 0 through pi by 2. So now we have to use the double angle formula, 1 minus cosine 2 theta over 2. So it is 2 and 4, that will give you 2ab. Then if you integrate the inside, it is going to be theta minus 2 sine 2 theta over 2 between 0 and pi by 2. So it is 2ab times pi by 2 minus sine of 2 times pi by 2, that will be a 0. At the lower limit, everything becomes 0. So it is pi ab. That's the area of the ellipse. Hope this video helps.